Okay. So, hello everyone. My name is Slapjums, and today I will be talking about lithium-ion batteries. The discovery of lithium goes back to 1817 by analyzing a petalite ore mineral. But the material itself was isolated only in 1821. Lithium is the lightest metal on the periodic table. But only a century later began the studies of lithium electrochemical properties. Due to its high specific capacity and performance, it was quickly realized that lithium could serve very well as a battery anode. But until that, lithium has been used in medicine for many years. This is an actual poster from mineral wells in Texas, where lithium was containing, among other minerals, and it was very popular back in the day since people suggested that small doses of lithium could be preventing kidney stones. Also, lithium was used in treating various depressive illness. And in the 1970s, during the oil crisis, Dr. Michael Whittingham, working at ExxonMobil, was dreaming about a fossil fuel-free energy source. And this led him to start experimenting on a concept of a rechargeable battery. Specifically, he and his team realized that if lithium ions would be held between titanium disulfide, the ions will start going back and forth, creating electricity. However, the limitation of this technology was that sometimes battery was performing unstable and causing it to ignite. And in 1976, Exxon emerged with the first patent application of a lithium-based battery. After that, in the 1980s, Dr. John Goodenough was good enough to understand that lithium cobalt oxide is a far more superior material, since lithium cobalt oxide environment was better with lithium ions, and it was easier to handle during the manufacturing process. The discovery of this material as a cathode was a breakthrough, because at that moment you could power compact and relatively large devices, which was far more superior than anything on the market. Also today, the cutting-edge technologies are essentially made out of lithium oxide, with cobalt largely replaced by nickel and manganese, since cobalt mining mining processes are referring to poor working conditions. However, in his technology, the unsafety of the battery still remained an issue. This led Dr. Akira Yoshino to start experimenting with carbonaceous material. He understood after experimenting that actually lithium-ion battery was far more safer without lithium metal. And in his architecture, the lithium ions were floating from one separate host to another, from lithium cobalt oxide to graphite. And this technology is actually also used today. Also, he found a way how to coat the active material on thin metal foils and separated the positive and negative electrode by a thin mesh, which is now called the separator. And only this led lithium ions to compete with the current technology, battery technology, the nickel metal hydride battery, which was dominating the market at that time. In the 1990s, a typical video camera was so large that it could barely fit on the shoulder of a cameraman. And thanks to microelectronics, Sony has managed to make the battery much smaller. However, the camera, sorry, much smaller. However, the battery still remained large. So Sony, as a video camera manufacturer, needed a battery that could be powerful enough to charge the camera, but small enough to fit inside. So Sony turned to the only battery material that could satisfy their need, the lithium ion. And in 1991, by combining Goodenough's cathode with carbon anode material, Sony has built the first commercially viable rechargeable lithium-ion battery. The result was an overnight success, and the battery became huge sellers. The newly invented lithium-ion battery was a breakthrough. It was a battery that was sufficiently lightweight to be used in portable electronic devices, and another key benefit was its lifetime. The battery could be charged and discharged many, many times, which we keep doing for years. Now, lithium-ion batteries are on the verge of their greatest success, the energy sector. We have entered an age where lithium-ion battery industry have become an integral part both of the electric power grid and the automobile industry. The lithium-ion industry has transformed from a relatively minor player concentrating in consumer electronics to become a foundation of the global economy. And those great achievements led to the 2019 Nobel Prize in Chemistry shared by Michael Whittingham, John Goodenough, and Akira Yoshino. Those three world-leading scientists deserve enormous credit for their contribution in developing the lithium-ion battery technology. And the decision on awarding more than one scientist correctly reflects that this technology didn't come out of the dungeon laboratory of some individual genius, but rather was a history of systematic problem solving. And at that same year, not too far from Sweden, a company, Adianana, was born. I am the CEO and founder of this company, and our goal is to create the next generation lithium-ion battery. Now the European Union is strongly pushing the industries to go green. Everybody understands that the climate change is here and it is mainly caused by CO2 emissions, where the transport sector is responsible for 26% out of all emissions. Because of that, the automotive sector has shifted its focus to electronic vehicles. But still, there is a lack of number of sales due to the perspective of customers that the current range won't satisfy their needs. Also, the rising demand of electronic vehicles is causing a lot of CO2 emissions during production. And all of this can be mitigated if the total capacity and lifespan of the battery will be increased. Throughout the years, there was continuous technology development in order to make the battery more powerful, but on the anode side, things haven't changed drastically, and basically we are still using graphite as the main material which was implemented in the battery more than 30 years ago. The solution of Adianana is to substitute graphite with silicon, a material which theoretical capacity is 12 times higher. The problem of silicon is that during the battery charge and discharge, the material is increasing and decreasing in size, which is causing the loss of conductivity. And our solution is also enhance the material with graphene, which physical properties are almost related to diamond, and it can also flex relatively easy without breaking apart. Here you can see a more detailed explanation of what is happening inside silicon during the process of charges and discharges. And if the material is not distributed homogeneously, then as you can see, it started to form agglomerates with particles are sticking to each other, and then after increasing and decreasing, we have a loss of conductivity. The method that we want to propose and have done is that we can distribute homogeneously the particles embedded into the graphene layers and also tailor the size of the particles and their deviation. Here you can see in our simple solution how our material is performing in a real environment. So either we can reduce the weight by 35%, and this is how we can contribute by less mining of raw materials and less raw materials will be needed in the battery, or we can increase the range to 200 kilometers with the same battery size by prolonging the battery lifetime. Our further activities is to already move from laboratories to develop the material on a semi-industrial device, which will allow us to fully control the synthesis. And we want to create several different batches of our material and test it according to the testing protocols which were issued by our clients. We want to enter a market that is on the beginning of a very successful growth. We as a company want to focus more on the European market, since the production capacities compared to US and Asian countries is far more lower, and we see big investments coming both from the public and private sector. This is the client map of our potential clients, and the number of clients is constantly rising. We have already established connections with 3 of them. Everybody has signed the LOI agreements and issued to us this testing protocols, and after that would be ready to proceed to commercial relationships. Our clients' markets are tremendously big and keep growing at a high pace. And with solutions like Adianana, we know that we can even furtherly extend the application area and create new emerging markets. Thank you very much for your attention.